Welcome back, everyone. Ready for another deep dive? Today we're tackling something pretty mind-bending. We're going to explore the idea that the universe, like at its most basic level, isn't built on matter or energy, but on pure information.
And not just that, the idea is that there's this kind of cosmic balancing act going on with this information. Every action having an equal and opposite reaction, but at this fundamental information level. It's a wild concept, and we've got some really interesting material to dig into.
So what we really want to get out of this deep dive is to understand the concrete predictions that come from this idea. If information is the bedrock of everything and there's this inherent balance playing out, what does that actually mean for how the universe works?
Exactly. The exciting thing is this isn't just some abstract philosophical idea.
Right.
It could have real testable implications. So let's start by unpacking this whole information as the foundation concept.
All right, so picture this. Before the Big Bang, before any particles were zipping around, there was just information.
Pure information.
Like the ultimate blueprint, the seed of everything.
Yeah. And in this view, energy isn't the fundamental thing. It's actually a byproduct of how this information interacts. Imagine different data streams, colliding and creating energy.
And then matter, the stuff we see and touch, that's just energy that's kind of stabilized. Like think of a ripple on a pond becoming a standing wave. So the physical stuff is, in a way, a second-order effect of this underlying information framework.
What's really neat is how this idea connects with insights from totally different fields. You've got Claude Shannon, who gave us the math to understand how information is structured. And his work suggests that information is this real, quantifiable thing. It's not just some vague concept.
It's fundamental.
Right, like energy or space. Then you have folks like Stephen Wolfram talking about a computational universe. So reality isn't running on these smooth, continuous laws, but more like a computer program with discrete informational rules. And then, of course, there's John Wheeler and his idea of it from bit.
Oh, yeah, I love that one.
It really captures this idea that physical stuff comes from informational bits. It's not just a trendy concept. There's serious intellectual weight behind it.
Okay, so if information is this fundamental building block, how do we get the forces that shape the universe, like gravity, electromagnetism, those nuclear forces holding atoms together?
Right. The material we're looking at suggests a pretty radical shift in thinking. They say that these forces aren't really these fundamental pulls and pushes, like we often imagine.
It's more like,
They're structured changes in the density of this information. Imagine a network, and a knot of information creates tension, and that tension shows up as a force. It's like these informational variations pulling on these cosmic strings.
okay, I think I'm starting to get it. So let's start with gravity.
Good one. The usual picture is this invisible hand pulling things together.
Right, but this is saying it's more like,
A flow, right? It's a flow arising from differences in how concentrated information is in different places. A lot of mass means a lot of information clustered together. So gravity is basically the universe trying to even out these informational concentrations. Like, think about water slowing downhill.
oh, I like that analogy.
And what's cool is it might explain why we haven't found this graviton particle, the one that's supposed to carry the force of gravity.
Right.
Because it's not about a specific particle. It's a built-in property of the informational landscape itself.
This is where it gets really interesting, and we start to see some cracks in our current understanding and potential tests, which is what we're all about. This idea predicts that gravity should act differently in environments where information coherence is super high.
Right. Information coherence. It's a bit of a mouthful.
So imagine an orchestra with all the instruments playing perfectly in tune and rhythm. That's high coherence. Now think about the quantum vacuum, the emptiest space imaginable, far from any matter.
Right. Empty space.
But the idea is the underlying information structure there might be unbelievably coherent.
Super organized.
Exactly. So if gravity is all about the structure of information, then in these highly ordered informational states, the gravitational interaction might be subtly different.
Like a slight change in tuning.
Yeah, it's not something we can easily test in our daily lives, but it points towards some really cutting-edge experiments looking at gravity in these carefully controlled, near-empty
Oh,
environments.
solely. This isn't just about reinterpreting what we already know. It's suggesting new avenues for scientific exploration, which is super exciting.
For sure. Okay, so let's move on to electromagnetism. That's the force behind Light, electricity, magnetism, all that good stuff. Usually we think about electric and magnetic fields as these fundamental things, and the photon as the particle of light. But through this information lens, it becomes something totally different.
Yeah, it's almost
The most efficient way for information to travel in this cosmic information network.
like super fast data transfer.
Exactly. The photon isn't so much a tiny particle, but more like a pure packet of information being transferred, like sending a compressed file.
No wasted space.
And the fact that light always travels in a straight line at the speed of light, that's not a coincidence. It's just the most efficient way for information to move through the informational fabric of the universe.
Makes sense. Straight line, no detours, fastest possible speed.
And here's another testable prediction. If electromagnetism is all about the most efficient transfer of information, then in places where information coherence is super high, like in Bose-Einstein condensates, light should act differently.
Bose-Einstein condensates. That's where you cool down a bunch of atoms to almost absolute zero, right?
Right, and they basically become indistinguishable, acting like one giant quantum entity.
A super atom.
Yeah, so because the underlying information structure in these condensates is so unified, we might see changes in the speed of light, weird refractive properties, all sorts of unexpected things with electromagnetic fields.
And this isn't just some theoretical fantasy. We can test this stuff in labs.
Okay, let's get even smaller, down to the forces inside atoms, the strong and weak nuclear forces. This material suggests these aren't fundamental forces pulling and pushing like we imagine.
Right, not like the traditional picture.
They might be more like emergent phenomena coming from how information is organized at that incredibly tiny quantum level.
Take the strong force, the one that holds quarks together inside protons and neutrons.
Super strong glue.
Yeah, it's like the fundamental logic of how those basic information units, the quarks, relate to each other. The rules that say how they combine and interact.
Like the grammar of the universe?
Yeah, kind of.
Okay, and what about the weak force, the one behind radioactive decay?
That's more about informational instability and how things transform. So these unstable informational configurations at the quantum level shift and become more stable, like a system reorganizing itself.
Got it. And what's exciting is that this leads to a prediction that we might be able to uncover totally new ways for nuclear particles to bind together, stuff beyond our current understanding of particle physics.
By messing with the coherence levels of those quantum fields,
Yeah.
the underlying informational structures.
Exactly. So the atom as we know it might not be the only stable configuration.
There could be a whole world of possibilities.
This is seriously pushing the boundaries. And it brings up an even bigger question. If information is at the root of reality, where does it come from? And the sources we're looking at dive into some really wild ideas here.
Seriously mind-blowing stuff. One idea is that the universe is like a self-referencing informational loop, constantly making and processing itself. It's like the holographic principle, where all the information inside a 3D space can be encoded on its 2D boundary.
Like a hologram.
Right. And in this view, every bit of information is connected to every other bit in this ongoing, self-sustaining dance.
Okay, and then there's the really out there idea, the one that sounds like science fiction, the universe as a simulation.
Ooh, yeah, that one.
If information is primary, maybe our reality is running on some massive external computer.
It's trippy, but it actually kind of fits with some of the weirdness we see in quantum mechanics,
Right.
like that inherent uncertainty or even the holographic principle itself.
Right.
Maybe our 3D world is just a projection from a higher dimensional computer.
Whoa.
And then the third big idea is the universe as a living system, like information acting like a self-organizing entity, almost like a cosmic intelligence.
So the forces we see wouldn't just be random interactions. They'd be like the communication rules of this vast, self-aware informational network.
It's definitely a different way of looking at things.
These are some huge concepts to wrap your head around, but there is a potentially testable prediction related to where this information comes from. The idea is that if information is fundamental, we should see times where energy just pops into existence from seemingly nowhere.
Because of shifts or reorganizations in the informational field.
Right. And this could explain those mysterious vacuum energy fluctuations that physicists have been scratching their heads over, those virtual particles that appear and disappear in empty space.
They wouldn't just be random quantum jitters.
They'd be actual signs of these underlying informational dynamics, little bursts of energy from shifts in the fabric of information.
Okay, so let's shift gears a bit and talk about this principle of equal and opposite reactions, but through this information lens.
Everyone learned Newton's third law back in school.
For every action, there's an equal and opposite reaction.
Classic. But the material we're diving into suggests this isn't just some rule for physics class. It's a deep principle woven into the fabric of an information-based reality.
And if the universe is built on information, this equal and opposite idea makes total sense.
Wow.
For any system to stay stable, especially one that's constantly processing information and referring back to itself, you'd need balance. If there was a constant imbalance in the informational forces, the whole system could fall apart.
Right, it would be chaos.
Exactly. And if you look at information theory, there's often this built-in symmetry. For every piece of information, there's a not that state, a complement. So if something comes into being at the information level, its opposite has to come along for the ride to keep everything balanced.
So it's not just about things pushing and pulling. It's about information needing its counterpart to maintain stability.
Right. And, of course, this ties back to the law of energy conservation. Energy can't just appear or disappear out of nowhere. It has to be balanced.
Okay, and what's amazing is that this principle pops up everywhere in the universe.
Literally everywhere you look.
You've got forces in opposing pairs, gravity pulling things in, balanced by the expansion of the universe pushing out, positive and negative electric charges, matter and antimatter, the strong force holding particles together, and the weak force allowing them to decay.
It's like two sides of the same coin, but for information.
And this leads to another prediction. If we ever find a new fundamental force that doesn't fit our current models, its equal and opposite counterpart has to exist somewhere, even if we can't detect it yet.
It has to be there to keep things balanced.
Right. It's a prediction based on the fundamental symmetry of an information-based universe, like a cosmic conservation of opposites.
I like that.
So taking this even further, what if what we see as opposite forces are actually just the universe's way of staying balanced?
Like a self-correction mechanism.
Exactly. So information can't exist in a vacuum. It needs its complement. Forces are the tension between these opposing informational states, and the opposite force is just the system automatically fixing any imbalances.
That's a really elegant way to think about it.
And this could change how we see some of the biggest mysteries in physics, like those constant quantum fluctuations in empty space. Maybe they're not random noise. Maybe they're a direct result of this informational balancing act.
Little seesaws in the fabric of information.
Yeah, exactly. And even the expansion of the universe, pushing outward against gravity, could be part of this grand self-correction. It's like the universe is constantly fine-tuning itself.
And this even touches on the arrow of time, why time moves forward.
Yeah.
Maybe it's connected to this ongoing balancing act, this constant drive toward equilibrium in the information matrix.
So time is like a measure of the universe balancing itself.
It's a pretty wild thought.
It is, and it brings us back to that classic philosophical question. Something versus nothing.
The big one.
If the universe is fundamentally informational and needs balance, then the idea of pure nothingness, a total absence of information, might be impossible.
Unstable.
Right, because even a tiny bit of information appearing out of that zero state would need an opposite anti-bit to balance it out.
Leading to something popping into existence from nothing.
Which leads to a really important testable prediction.
That physicists are actually working on right now.
If this informational balance idea is correct, even those quantum fluctuations in empty space should have zero net energy.
Because for every tiny blip of positive energy, there'd have to be an equal blip of negative energy, keeping the overall energy balance to the vacuum at zero.
That's a really subtle but huge prediction.
It could really change how we understand cosmology and quantum field theory.
Okay, so let's get to the fun part.
The what-if section.
What are some potential practical applications if this whole informational view of reality turns out to be right? The sources we've looked at offer some pretty tantalizing possibilities.
It's definitely speculation at this point, but some of it's pretty wild.
One idea is harnessing zero-point energy. If those vacuum fluctuations are part of this balancing act, maybe we could figure out how to tap into that energy.
By messing with the symmetry a bit, then letting it snap back to equilibrium.
Right, like siphoning off a bit of energy as the universe rebalances itself.
It's a long shot, but the potential is huge.
Another idea is controlling matter at the information level. If particles are basically stable configurations of information, could we learn to restructure that information to make new materials?
like materials with properties we can't even imagine right now.
Yeah, or even messing with fundamental constants. It's super far out, but it's a mind-blowing possibility.
It is. And the sources even talk about enhancing human performance through information coherence. Like if our bodies and minds run on information, could we optimize them by aligning with these cosmic balances?
So better health, better cognition, all because we're in tune with the informational structure of the universe.
It's pretty fascinating. So to sum up this deep dive, we've explored some really big, radical ideas. We talked about gravity acting differently in high coherence environments, unusual electromagnetic effects in Bose-Einstein condensates, new types of nuclear binding, energy appearing from nothing, the need for equal and opposite forces, and the idea that those vacuum fluctuations should have zero net energy.
And all of this is based on the idea that the universe is built on information with this inherent balance woven into its fabric.
Yeah, it really makes you think, right? Maybe everything we experience, from tiny quantum particles to giant galaxies, is just the playing out of these fundamental information patterns.
All driven by this elegant dance of balance.
So here's a final thought for you to ponder.
The big one.
If reality is this complex web of information, with this unbreakable drive toward balance, what happens when we try to mess with that balance? Even if we have good intentions.
Like, are there limits to what we can do?
And what might happen if we push too far?
It's a question that really gets to the core of what it means to exist and our place in this information-driven universe. And that's something worth thinking about. Thanks for joining us on this deep dive. We'll see you next time.